So we'll be discussing in this group what gravity really is in regards to movement, not necessarily mass. I look at mass more as an inanimate object. If I were to drop a cup, and if I dropped me, yes, we would fall at the same rate. What I'm looking at gravity is, again, I'm not being pulled to the earth. It's not a pulling force. I don't believe it's a wave. It's based off of rotational movements. Rotation of the core of the earth is what we respond to, just as the earth is responding to the rotation of the solar system. And any living organism has to have oppositional rotational movements for sustained life. I look at sustaining life as the exchange of molecules, because obviously you can't grow a plant on a sun, but the sun is, again, a constant example of the rotation, inner cores, outer cores, and opposition. And then again, the solar system, what we call our space highways, are actually, again, rotational, almost tubes in a sense, because people need to visualize. And we tend to visualize, still to the floor, which there's no floor in space, but there's really no floor here, right? When I go to stand up, I'm not pushing my feet off the floor. In other words, if I put my feet on the floor and push really hard, I'm not going to stand up. It's just not how we work. Gravity in movement is different than gravity in motion, but most physics is still applied as a motion. So when I say rotational movement, they're thinking torque versus a linear axis point, let's say. There's no linear points in the human body, right? But also, too, we either are opposing gravity, just like I'm doing now. I'm not falling off the table as I'm talking to you. Or we're succumbing to gravity. So there's either an up or a down in the process. But we're also going to be discussing how we organize within movements within these principles, but also when these principles fail. I just wrote a book called You Can't Get to Mars Without Me, The Rules of Gravity. It is 21 new theories in biological gravity. I've been influenced by gravity for years. I was reading a book on Einstein to my boys, and we were describing the shuttle. And they weren't around in the program. The program retired in 2009. They were just young kids. And just that majestic ship taking off, the escape velocity, the rotation out. It was there. About 3 hours later, I jumped from my bed and I said, it can't be that simple. Everyone with special needs, doesn't matter if it's stroke, Parkinson's, to children, the common denominator for their movement structure is lack of the ability to respond with rotational movements. I presented my first theory of gravity in 2017 to Oxford, the movement conference at Oxford University. And seeing aspects of Dr. Neil deGrasse Tyson and other experts say that we know very little about physics in the human body. To put more theories with my work that I do in movement lesson, and he said, one of the comments was, we know very little about the gravity because it's very weak force. Anyone can just lift their arm. And I was on an airplane, didn't have Wi-Fi, and just was taking notes off of it that, I found at that point 20 deviations to what was being stated. And I wanted to do the research as to what were these laws to put them all together, because I just figured someone else had done them, theories. And no, you can't get to Mars without me. The theories that I'm presenting, the human body cannot make it more past a year in space. I can't help the radiation. That's going to be someone else's task. But as far as having functional movement in outer space and organization to opposition to gravity, which there's no gravity in outer space, I get that. But we still have to set that up, because that's how our nervous system, our central core, our vestibular system organizes. It's not about the brain and movement. It's about the whole body as a whole system in relationship to gravity. So that's my niche and where I'm coming into play.